Hi kids, video 16 is on the different kinds of energy that we're going to be dealing with as we move through the end of our conservation unit. The essential question is, what is energy and how can I tell what kinds of energy are in a system? So energy is going to be a new variable for us. We're going to use the capital letter E to represent energy in equations, or as we write it in our work. Energy is defined as the ability to make something happen. And you may have learned about kinetic and potential energy in middle school, but in high school, you'll discover that those are not actually energies, but categories of energy. Kinetic energy is any kind of energy that results from movement of objects or particles, and potential energy is any kind of energy that is stored up in objects or particles. No matter what kind of energy we're dealing with, we have the same units, which are the joule, which is a capital J. You may have also heard the units of calories. That's something that food energy is measured in, but you can convert back and forth between joules and calories. Just for your reference, something like a stretched rubber band would have a few joules of energy because if you let go of that stretched rubber band, it can make something happen. Picking up a pineapple, the amount of energy that pineapple has when it's lifted up is about 10 joules of energy. Something like a spinning ball has more energy than that pineapple, let's say hundreds of joules of energy, and then that horse running would have thousands or even more joules of energy, and we'll talk more about the kinds of energy those things have in a minute. So as I mentioned before, kinetic energy is the energy of an object that has motion itself or has parts of the object that is moving. So the first kind of kinetic energy is EM, and this is probably the kind of energy that you learned about in middle school. We're going to call it motion energy, and it's the energy stored up in an object that is moving. Some examples of objects that have kinetic energy: we've got turtle and race car. The turtle is going to have a lot less motion energy than the race car for two reasons. The first is because the turtle has a lot less mass, and the second reason is the turtle is going a lot slower. So the motion energy of an object really depends on the amount of mass it has and how fast it's going. FYI, this is an example of stuff you would want to write down for sure. It's not on the slide, but this is important information, what motion energy depends on. So moving forward, make sure you write down this stuff as well. The second kind of kinetic energy is called rotation energy. So this is an object that is not moving itself. It might be staying in place, but it is spinning. Some examples of objects that have ER, rotation energy, are bike tires and planets. Bike tires have a lot less rotation energy because, again, they have a lot less mass, and also they're spinning a lot slower than the planet is, right? Our planet has to rotate once per day, so we've got that planet spinning pretty fast. The third kind of kinetic The second category of energy is potential energy. As I mentioned before, objects have potential energy if their shape or position stores up some kind of energy. Probably in middle school you talked a little bit about gravitational energy, which we're going to call EG, okay? And objects have gravitational energy when they are lifted up away from another object. Usually that other object is Earth. So when you pull things away from Earth, they gain energy, because if you let go of them, they're going to fall back towards Earth, and that causes something to happen. An example of an object with a small amount of gravitational energy would be a snowflake. Okay, it's falling down, so it has some energy, it's up in the air, but it doesn't have a lot because it has a small mass, again, and because it's not that high compared to the next object, which is a space shuttle. Space shuttle would have a lot more gravitational energy because it's got a lot more mass and because it's a lot higher. Second kind of potential energy is called electrical potential energy, or EE. Electrical potential energy is stored up in charged objects and how close or far away they are from each other. An example of an object with not a lot of electrical energy is a single electron, and you probably can predict that a power line actually has a lot of electric potential energy in it. The third kind of potential energy we might be mentioning is ES, which stands for spring energy, or sometimes elastic energy, because it's not always springs. So, would you please take a few minutes and summarize this? What is energy? What are the different categories of energy? And how do we kind of make predictions about how much energy an object or a system of objects is going to have? Thanks for watching.